Hello, and welcome to Philosophy-Sciencing.
My name is Ruby,
And I'm Nathan.
and today
And
we're going to talk about transparent wood. And-
yeah. Which, like, weirdly, for some reason, apparently we were both, like, independently reading about that. Okay, actually, since we're on this topic, so what did you learn about transparent wood?
um, well, it has all the pros of wood and like the pros of like a window, as it lets
Mhm.
light in, and um, makes your wooden cabin not dark. And it's just like the energy footprint or like the carbon footprint is quite low. And like the general idea is like you take some wood and you bleach the crap out of it and then you fill it with like a clear resin, and you can imagine like that material creating windows that you can
Mhm.
see through and it'll just be continuous with the rest of the wood house, which is quite nice.
So
That was
so
basically it.
what are the like so what is the advantage of using like a wooden window over a normal like glass window? Is it
Yeah,
like
so that was the main. So first, the production of glass is really energy intensive. You have to heat silica like you have to silica really hot to make
Mhm.
glass, and it's just like energy unfriendly like stuff. And once it's installed, if it's hot outside and you want it to cool, it loses the cool, like it gets warm really easily. If it's cold outside and you want to keep it warm inside, it also loses heat really easily. Like it's just energy inefficient, like
right?
windows
So
are.
it isn't a very good insulator, you're
It's
saying.
a poor insulator, and to make it a better insulator, you use thicker glass or multiple layers of glass with stuff in between it, and that just adds more glass that you have to make. And like it's just like think of the temperatures that we have to take glass to so that you could like blow it into like glasses and stuff. That's the kind
Mhm.
of glass that is easily blowable. Like, do you know what I mean? And they have to like
Yeah.
use this like little glory hole thing that's like some crazy thousand degrees. Imagine having to make a window the size of these windows, like floor to ceiling here behind me. Like how much heat is required to make that kind of window, right? Do you know what I mean? Like it's not an efficient system. And then now it's approaching winter and it's like freezing out in Boston. They're gonna have to heat this room, and then like every time they heat this room, like a bunch of it's just gonna get lost to the frosty windows out there. So anyway, transparent wood.
Yeah.
Possible replacement
And so
for
this so I
floor to
get
ceiling
and this
windows. Yeah.
helps because kind of the wood just like it has a structure that is it because it like has a bunch of different kind of cells in it that makes it a more efficient insulator versus just like this thin pane of glass.
That's true. I was like, well, is it better to just have like a giant piece of resin, like acrylic,
Right.
the plastic acrylic? And actually, there's some really nice things about wood. So I'm not a material
Uh-huh.
scientist, and they could
Yeah.
probably tell you more. But I just read the introduction for this. So wood naturally has this like the cellulose structure that's like kind of layered and has like pockets that you would basically replace with the plastic resin. And so it is actually a giant plate of resin, but instead of just like being poured, it will like gives it structure integrity in a way that um it's like using nature's scaffold instead of
Right.
using like a homemade a synthetic scaffold, which I guess could be engineered as well. But um I don't know. I actually don't know if it's actually cheaper or less environmentally friendly to go with a fully just resin with like a scaffold that is man-made. I don't know,
Yeah.
but I read about the wooden things replacing windows and I got excited. So,
Like
um
I also went down like a rabbit hole about wood recently. And I think that was one of the things I was reading. It's like because wood is grown from these tree cells and it kind of grows in rings, it has a lot of like interesting mechanical properties that you don't really get from other like manufactured things, like being extremely strong, kind of parallel to the wood fibers, for example.
yeah, it's like
Yeah.
stronger and has like a structure that's more tree-like. And like if you imagine like putting it vertically on, floor to ceiling windows, in a building where maybe like the ones you don't have to look out immediately and have like full transparency to like experience the skyline or whatever, maybe like those windows should be made of wood.
Yeah. Or alternatively, I mean, this is kind of an interesting idea. Like, if you have like your building has to have a roof, and like the cool thing about having transparent wood is presumably it's like it's a structural material too. Like it will like
Yeah.
support weight versus glass won't. So you could take structural parts of your building and make them transparent so that natural light can get in.
Yeah. I thought it
Neat.
was a really cool,
Yeah.
cool system. So if you didn't get the gist by now, today we're just highlighting cool ways that people have been sciencing their way, or we're trying to help with climate change and global warming. And there's just like these like cool, innovative things that are happening. They're happening right now. That like if we didn't look, like I know it was just like we're just highlighting them. If we
Yeah.
because we're excited
And I think,
and
yeah. And I think especially like these kind of unconventional ways that are like I like okay, I kind of have a soft spot for these like for some reason in the 2000s there were like 5 different movies that came out like about asteroids hitting the earth, and they all involve like astronauts have to go up and like blow up the asteroid, and then they do it, and then like the earth is saved, and kind of I don't know. I feel like I have a soft spot for that kind of like problem solving like approach. Like, can we do something really big and ambitious and just kind of like solve this problem? Which I think also we're going to discuss like maybe there's reasons we don't want to do, but I think it's a really interesting thing to think about. Are these kind of like radical technological solutions we could be deploying to
yeah.
save the world?
And
Yeah.
the nice thing is like it's not just like astrophysics that are doing it, right? It's like all fields of science have people thinking about these problems. Like I don't know, the material scientist and like the botanist, I guess, that was like, yeah, let's make this tree into this better skeleton for your plastic. Like these are very innovative ideas that are not necessarily like the climatologists or like the meteorologists are like climate change is happening. Let's fix it. They're not the ones. I mean, they are coming up with ideas, but these are ideas coming all from all fields, all across the board. And we're going to try and highlight some like different methods that people have come up with using their expertise or like whatever they're interested in, which is cool. But let's start with the asteroid related ones, because you have some like space deflector ones, right?
Yeah, I'm not sure if there's any that are specifically asteroid related. Like, oh yeah, we get an asteroid to smash into the Earth, and then like our global warming problems are like not a big deal anymore.
Have another mass extinction. Well, actually,
like,
we're in a current mass extinction, so I don't know if it'll get worse.
Actually, like I think we've talked about the like En-ROAD simulator, right? And I think I was doing this with a friend, and like their first instinct was like, what if we cut the population in half? And like it turns out it doesn't even help that much. But this is a simulator for like looking at the effects of different climate policies. It's really cool. But I think actually
we should definitely put that in the chat if we can.
I'll put it in the chat. It's
at the media, not the media, at the MIT museum, like on like the second floor.
Yeah, but it's also just online. Like you can play with it on chat.
It has like what is it called? It was like a exhibit. It was like an exhibit.
Yeah, it's an exhibit in the Media Lab or in the MIT
museum.
Yeah. I just put it in the chat though.
Oh, you did? Okay, very good.
Yeah. Anyway, I think one of the kind of depressing things about this is that it like shows how hard it is for any one policy to like really change things very much. But I was looking into this interesting, so this is an idea that's been kind of floating around for a while. And the idea is so global warming is caused by the Earth absorbing too much heat from the sun instead of reflecting it away. And that basically increased greenhouse gases increase the amount of heat that gets trapped instead of getting reflected. And so one idea that people have been talking about for like a couple decades now is what if we put something else in the atmosphere that makes it more reflective and therefore counteracts the effects um, of the carbon dioxide. And interestingly, I thought a really interesting thing about this is that actually we have done this unintentionally. So it turns out, like from like the 1940s through now, actually we saw this kind of strange dip in the Earth's temperature, actually a sort of global cooling, and it has such since like been kind of reversed by global warming. But actually, like if you look at the Earth's temperature, it isn't just straight and then it starts going up. It's actually like that, and then it goes down, and then it goes up. And the reason for that was that industrial processes that produce a lot of aerosols, and in particular aerosols that contained compounds called sulfates, actually were very effective at reflecting back the sun's light to the point where we actually caused some artificial cooling of the Earth before that got overwhelmed by the warming of the Earth from the carbon dioxide.
I understand why you're like, and should we do it? I was just like, what do you mean we should definitely do it? And I was like, wait, actually, this is one exception where I'm like, actually, we should not do that again. That sounds terrible. I like breathing air that's not polluted.
I mean, okay, so the people who are in favor of this is one thing that they point out is that you can release these chemicals selectively into the upper atmosphere and not into the air that we breathe.
Oh, so like but like, won't gravity bring it back down? Like, it's not gonna stay in like in the atmosphere forever,
I
right?
mean, so the one that it depends exactly on what kinds of chemicals you use. So one approach is called marine cloud brightening, and essentially it consists of basically spraying seawater into clouds, and that makes the clouds slightly more reflective. In that case, kind of the fallout from it, like you're producing aerosols, but the aerosols are just salt and they fall back into the ocean, which is already salty. So it's like the environmental consequences are not too bad. The other one that's been looked at is looking as sulfur dioxide, which is pretty bad to breathe in. We actually basically banned a lot of the processes that produce sulfur dioxide on the ground because it was causing acid rain and various health problems. But if you put it up in the upper atmosphere, it tends to stay there until it either degrades or it kind of just falls out. It gets captured in water and falls as rain to the ground, where it then degrades.
Wait, but we still get acid rain though, right?
I think most of it actually degrades. That's a good question. So when I was listening to the podcast, I think they were arguing that most of it would actually degrade into something else when it's in the upper atmosphere. What's falling back are just kind of the sulfur in different forms.
Okay. The problem with these methods is that one, I think it'll be kind of cool if it works, but two, it's really hard to control something that's aerosolized. Like it could get blown away. It could, it's very difficult to control a gas or not
Right.
or little particles of liquid in gas. It's like a cloud. It's like trying to control a cloud of chemicals.
Yeah, exactly. Yeah.
That seems very difficult to do.
Yeah, and I think I think this is where we kind of get into the ethics of it. Because this is like basically the main argument that's made about it is there's companies right now that actually want to do this and use it to essentially sell carbon credits or sell credits for offsetting the effects of carbon emissions. And they're I think the best known one of these is called Make Sunsets. And what they do actually, it's pretty cool in an engineering sense. They fill balloons with sulfur dioxide. Those go up into the stratosphere and then explode. So it lets them kind of selectively release it only into the upper atmosphere. And then it presumably stays there for about a year before it breaks down and increases the Earth's reflectance a little bit. And so they actually want to scale this to a point where it could kind of cool the entire planet. I think that I found when I was looking this up, there so a bunch of scientists were like, you should not do this, basically for the reasons that you said. Sorry, let me turn the lights back on.
Yeah.
That there is unknowns about it, and that, and in particular, one of the big unknowns seems to be that kind of, if you do this, it could affect things like precipitation patterns in different ways. So you could cause like droughts in certain local areas, or you could cause stronger storms in different areas, or interfere with crop growth in different areas. And it's really complicated to say how would this actually affect like kind of acute weather, if that makes sense.
Like you can cause certain things. Yeah, I could see that, because seeding clouds that's like a thing when you want it to rain more in a place, right? Like they'll like spray up iodine or something, and like the particles will help water particles clump, I guess, and then it becomes heavier and it rains more often. Or like if you don't want it to rain in a different place, like you'll seed it earlier, and then like it'll rain here instead of over the Olympics.
Yeah.
Over the Olympics.
And it's like, it's really controversial. So there was some like floods. There are some floods in Texas like a year ago, and actually there was a bunch of conspiracy theorists who thought that those were caused by people doing like cloud seeding.
Like upwind.
Exactly. And like it wasn't. It was just like it rained. But like
I'm just imagining all the wars about like water. Like I don't know, we grew up in California, so we learned about like all the logistics of like sharing water. It's like extremely litigious. But imagine if it was like the airways by wind, like eddies, like the earth turns a certain way, and there's certain like patterns in the sky, like in the air. Like imagine if you're upstream of someone and you get sued because you see, do you know what I mean?
Stealing their water.
But like by air. It's not just the rivers you're trying to control,
right? You're stealing the water from the air. So this is actually a thing with cloud seeding. Like this is actually a reason why people don't do cloud seeding sometimes, is because of that kind of controversy.
Okay, I can see that. And like floods can be bad, right? Like if you live by the water, like you can just get washed away and at sudden like water bursts. Yep. Okay, cool.
I will say so like the interesting thing about this approach is there are less concerned about like, okay, well, people use this to like steal someone else's water. It's like it's so unpredictable that it's more kind of like people are saying we're not exactly sure what would happen. We don't know which areas would get more water or less water, and
that's true. Like, you're gonna have a really hard time proving who stole whose water.
Right. Like the same reason, like it's really hard to say, like, okay, is global warming like making this particular kind of storm worse? It's like the same problem. You like need like decades of research to like start to get a handle on it.
Yeah. No, okay. So what I'm actually more scared of, like I'm actually okay with it being tried once or twice. What's scary is like, what if it like catalyzes something that's like, that's close to the tipping point and might happen, but right now it's not that bad. But like we add these random seeds and like we inject sulfur dioxide into the atmosphere, and suddenly it does get really bad and it doesn't get better. Do you know what I
mean? Right.
We could accelerate
Have you seen
horrible
the show
weather problems.
Snowpiercer, or the movie Snowpiercer?
Yeah, I've seen a bit of the TV show. It's kind of like that. Yeah, what if we get a forever winter? That sounds horrible.
Yeah. I mean, okay, but I will say, I think one argument against that, again, is that we have done this by accident for like decades. And actually, so sulfur dioxide is still being emitted by some industries, and actually it seems like it is even still significantly cooling the earth. So it seems to have currently be cooling the earth by around 0.7 degrees. And global warming is currently in the range of like about 1.5 degrees. So we're actually unintentionally offsetting global warming quite a bit through this other pollution, just through our industry. And I think I mean, to me, that kind of makes me feel more comfortable with this approach. I'm like, okay, wait, not only is it theoretically possible, but we've actually done it. And
Yeah,
it seems to work okay.
that's true. It's true. It's like here's a tried and true method. It's like, I mean, I guess every method is a little bit unknown at the beginning, right? Like if you don't try it, it's unknown.
Yeah,
The problem is like getting consent across all the human. Do you know what I mean? Like, how are we gonna
right.
make all the humans agree that this is a good idea?
And it seems like that's really the ethical question that everyone brings up is like not like necessarily that this is super risky, but that it's something that we should get like have an international consensus on before anyone does it.
Yeah.
I honestly I don't know if that's true. Um
Yeah.
I mean I guess the thing I was thinking about is like I mean any like anything we do to alter the climate, including trying to slow down global warming, is going to hurt some areas.
Yeah.
I think, and like, even like, for example, there's actually areas that benefit from not mitigating global warming. Like most of the North actually is actually going to be better off if the Earth gets a little bit warmer. And so if we're trying to take carbon dioxide out of the atmosphere, isn't that kind of that same argument? Like, oh, this is going to worsen the weather in these areas. Like that still applies.
Yeah. I mean, sure. I guess like some places will gain a little bit more of growable temperatures, but somewhere
Mhm.
else is going to get less, right? Somewhere else that's
Yeah,
not in the north.
yeah.
I have one that I guess I think it's less controversial, and I didn't realize was a thing
Mhm.
until I was in Iceland. So my partner and I went to Iceland to look at the puffins because that's something we
Yeah.
really like. It was like a lifelong dream of mine to see puffins.
See the
Um,
puppets.
so meanwhile, while we were there, we went to a like a energy plant, and in Iceland it's like on this massive fault, so it has a lot of geothermal energy, and like basically unlimited geothermal energy. Like no one pays for energy if you live in Iceland. Like you don't pay for hot water, you don't pay for like to cook anything. Like energy is free because it's so easy
Mhm.
to get to. And so that's like not the limiting resource there. And so one of the things that they're doing there now, the Swedish company was taking carbon dioxide and like taking massive amounts of it, pumping it into water, and then taking pumping that really deep underground until it hits like basalt rock, and then it forms like these carbonate um
Mhm.
like rocks like carbon rocks,
Mhm. So
like just
like
like
limestone, like
yeah,
yeah,
basically limestone. But like they just shoved it real deep underground, and they used the free energy from geothermal energy because they're in Iceland. And so it's just doing that right now. It's just like shoving shit into the ground, and it
what?
removes like 36,000 metric tons of carbon dioxide from the air every year. So it's and they're gonna expand. And I was just like, how like is Iceland just gonna be a giant like
Yeah,
carbon dioxide retrieval and shove it into the ground? Like is that just that's a kind of cool way. Like I didn't
yeah,
realize we could just reclaim it and shove it in the ground. At first I was like, oh yeah, okay, cool, you can convert it into these rocks, and I'm like, then what? And they're like, we have volcanoes, so we just throw it in.
yeah. I will say though, like, I mean, this is the Climeworks one, right?
Yeah.
They like so they got a lot of criticism because they like really failed to actually meet their targets for like capturing the carbon dioxide. So like I'll put this this news article I was reading in. I mean, so like this newspaper in Iceland kind of looked at their operation and they concluded that like not only are they only capturing like a small amount of the carbon they promised, it's probably like building their facility emitted more carbon than they have
Oh
captured.
no, that's so
um,
sad.
and it, yeah, I mean, it's like, I mean, I do think it's a cool idea, and like in theory, like the chemistry works, right? Like
Yeah.
you can take the carbon out of the air and bind it to other things. It seems like, and this is something that like a lot of environmentalists have been kind of concerned about. Is like because like the carbon in the atmosphere is not that concentrated. It is really hard to do this like air capture in a way that's actually like efficient.
Yeah, the other carbon capturing method I actually really liked, that I investigated, I Googled for the stream today, is one that has to do with phytoplankton. So
Hmm.
phytoplankton can actually take a bunch of carbon, and then they die or get eaten, and then they go to the bottom of the ocean, which is great, which is also a different way to do it. And so people have been thinking about like seeding, kind of like
Hmm.
causing like blooms, and I was just like, this sounds dangerous and bad. Like algae blooms are bad, but something like that, but for like phytoplankton that are really good at sequestering carbon. And there's several there's like a couple papers recently where they looked at viruses that are I won't say attuned, or like that's like their thing. They're like really good at infecting organisms that are good at capturing carbon, or the viruses itself like drives like pathways, metabolic pathways that are like carbon heavy, like, or require lots of carbon.
Huh.
And
So
so
the virus like programs an organism to start sequestering carbon, essentially.
pretty much. So then there's a bunch of viruses that are like, that do that because it like takes over, not takes over, but like it borrows the machinery, the metabolism machinery that uses the carbon part that phytoplankton naturally do, or single cell organisms, other kind of bacteria, whatever. So these viruses can infect these bacteriums or single cells or plankton or invertebrates like fungi, whatever, and then we can proliferate those, and then they could just sequester carbon all over the place, all over the ocean, all over. Do you know what I mean? Like like anywhere they can live, they will be sequestering carbon, and then when they die, or get eaten by a whale or whatever, it you know goes into poop and then goes in the bottom of the ocean. And that's another way to sequester carbon. And it's actually like they did this whole library search of all the different kinds of viruses on a bunch of RNA viruses turned out to be really good at this. Like I think it
Hmm.
was like in the hundreds of different kinds, and so they're currently testing them like in the laboratory to see, like which kinds of single cell organisms or which kind of invertebrates or fungi would get like most likely infected, and then like what happens to their metabolism afterwards, and if it would be good for sequestering carbon, which is kind of cool.
That's
Um,
crazy though. Like that you can just like that's a plan. It's just that they can to like reprogram these things to sequester the carbon.
Yeah, I mean they already do it. That's the thing. They
Yeah.
like they found these viruses in the ocean already. So like they already exist. Like they just
Hmm.
didn't know like what I'm saying is the ocean currently is sequestering carbon for us,
Yeah.
but like
Yeah.
we could make it do it even more. Do you know what I mean? Like we can be like,
Hmm.
"Oh, it's actually doing it. Pay attention to it." And then like, grow more of those.
Yeah.
um
Another example of the kind of like blow up the asteroid type approach that like I was talking about is there was a guy who basically just went and dumped a bunch of iron in the ocean in an attempt to stimulate one of these like plankton blooms.
yeah.
And it apparently worked in that it did cause the plankton to bloom and then sink to the bottom. It's unclear how much carbon it actually absorbed, which I think is the part that's kind of unknown about this.
Yeah.
But
And it probably sucked out a bunch of oxygen and killed a bunch of fish too.
actually, no. So the fish actually did better.
Oh, did they?
Um, yeah.
Excellent.
So actually, so he was, and this is why I'm kind of sympathetic to this guy. Is there was a local indigenous group that had declining salmon catches there, and so they talked to him, and they were like, okay, so if we pay you to do this ocean fertilization experiment, like the salmon depend on this like food chain that's fueled by the phytoplankton. So they were like, we think that if you make the phytoplankton grow, then we'll get more salmon. And it seems to have worked actually. Um,
Wow. Very
it,
nice.
yeah, I mean, it was like then like the government of Canada went after him, and like I mean, they were very much like, don't do that.
Yeah. Don't do
But
that again without a permission.
but like I don't know. I mean, like it like a big part of me is like, okay, maybe this is actually good. Like maybe we should just find like some rich person who wants to go out and like put a bunch of stuff in the atmosphere and like dump a bunch of like iron into the ocean. I think to me the cool part about it is that like in theory a rich person could just go and do this and in theory solve global warming. Like the
Yeah.
amount of materials that you need are like to the point where Bill Gates could just go and do it.
Yeah, and like a boat. Like you need
Yeah,
boats and
exactly.
like
Yeah. Like
well,
several boats. It's not just like him out in a sailboat, like dumping stuff in the ocean.
yeah. No, but the beauty is like here's like a thing one or 10 people could do that could have an
Mhm.
outsized effect. Do you know what I mean? Like
Right.
small like regular small humans that could
Exactly. Yeah.
do global like help. That's very cool. The other things I have are all reduce and reuse. Do you have any
Mhm.
other like technologies not reducing or reusing? Because we can
Um, did you know
otherwise I
that
can split.
Massachusetts is like has kind of the most advanced commercial fusion company?
Oh yeah, I did not know about this, but you did say you're going to tell us about it
Oh yeah,
today.
just like yeah. So there's a company based here called Commonwealth Fusion, which is actually now trying to build a fusion power plant. And so the point of fusion is that you can produce that you can produce power, nuclear power, without producing nuclear waste or having a risk of meltdown.
Yeah.
And it's a really interesting topic, but essentially the cool thing is that fusion reactions are not self-sustaining. So you can take, and also you don't need uranium. So you take basically hydrogen, you compress it extremely tightly so it turns into helium, and that releases a bunch of energy. But as soon as you stop squeezing it, the reaction just kind of stops. So this has been kind of a holy grail for energy production for a long time, and it seems like we're actually getting to the point where it might be feasible. Like we'll see, but there's actually a surprisingly large number of fusion startups now.
Ah, I'm like, are we worried about like a meltdown at any point? Like being in the epicenter, you're like, ah, Boston has the biggest one. And I'm like,
Yeah.
is it gonna be bad if it goes wrong?
So the good thing about fusion is like because it's not self-sustaining, if something goes wrong, it just kind of stops reacting. So like you have to actually kind of be actively compressing these atoms together. And much like in the sun, if you stop compressing them, the heat that's generated will actually force them apart and then they'll stop fusing. So it's very different from kind of like the problem with a fission nuclear reactor is that if it gets too hot, the fuel melts and it actually gets more dense, and that puts it into a state where it's reacting faster, and then you get a meltdown. The fusion
Yeah.
reactors kind of do the opposite.
Ah,
Um,
but it's still like you're fusing atoms together and it's emitting energy, right?
yeah, but
Oh,
like also the other nice thing about this is that it doesn't produce radioactive material. So
okay, that's
you
good.
yeah. So you take hydrogen isotopes and you smash them together, and byproducts are basically like helium, like normal helium, not radioactive helium.
Cool. Cool, cool,
So
cool.
even if the thing explodes, it's just like it releases helium.
Ah, okay.
Yeah.
I guess this
Although
is. Go ahead.
I was gonna say MIT does have a fission reactor too, so I'm like mildly worried about that. But
Yeah. I was, I was this is a side thing. I was like troubleshooting this device with the manufacturer and we like could not figure out why it was wrong and she was just like, are there like antennas? And then I was just like, I don't know, but there's a fission reactor over there in that direction. And she was just like,
you know that they're like you're kind of at the end of your ideas for troubleshooting when you're just like, is it because there's a nuclear reactor
like
there?
over in that direction, over yonder on campus.
Also,
Yeah,
I feel like if that ever becomes the problem, like we have other things to worry
that's
about.
true. We have bigger problems than that. Um, I was gonna say this one's a good one because we're smashing things together. This is a good place to talk about my I guess is this reuse. So one way is to reduce and then reuse. So my reuse one is actually about poop, which I don't so there's this method called hydrothermal carbonization, which is where you take like poop and like poop, plastic, anything that's carbon in it, and you convert it into coal. Um, and like the idea is that hold on, do I have? I think I put a paper in. Yeah, it's called HTC. I thought I wrote a whole thing about how it converts it. Oh, I put a figure. So basically, it takes like the raw material and it mixes it with water, and then like it processes it, and then it dries it out.
Uh-huh.
Like you create like a coal slurry, and then like they treat it and they do a bunch of stuff to it, and then you end up with like bricks or pellets that are coal like. Um, and then you can like reuse it. And the kind of like poop basically we're talking about is like cow poop, because that creates a lot of mass biomass.
Makes sense. Like it's an easy way to gather poop is to get it
Yeah,
from the
and there's other ways of reusing the poop and burps of cows too. So another big problem with cows is that it actually creates a lot of the methane. I think about 10% of the methane that's produced in the US is from cow farts and poops, cow farts and burps. And so
Mhm.
some scientists have been trying to reduce the farting and burping and actually make the food more, what's it called, like more efficient. Like you need to eat less food to
Mhm.
get the same amount of calories, by converting the food, or like by eating red seaweed. I feel like I talked about this on this stream before.
Wait, so they're
um
feeding the red seaweed to cows?
yeah, so or pellets. So it's actually this chemical called bromoform, which is in red seaweed specifically. And so they'll have these, and if you make like 1% of their diet red seaweed, in addition to their normal cow feed, I guess like grains and grass, they'll fart like 90% less
Oh wow.
methane. And methane's like odorless, and like they measured this. Like they had
Mhm.
cows inside like buildings that are like sealed and they collected how much methane was being emitted, and they reduced it by a lot, like something wild amount. And so it really works. The problem is that if you're grass feeding pasture cows versus like cows that are like dairy cows that are like stuck inside one place, it's hard to like make them eat it. And so like
Like
now
make sure they're eating the seaweed.
yeah, they
Yeah.
got to eat like 1% of their diet in that. So they're trying to like make these like salt blocks, like the lick blocks. Like they
Oh
put
wow.
the bromoform in it. So like when they lick the salt, they also get the
So
bromoform,
they
like a
can
heavy.
just give it as like a supplement rather than trying to like make the cows eat seaweed.
Yeah. So like that's like currently in the works. They're trying to like make it so that cows will like to eat it, and then they like fart and burp less and create less methane. And like the feed that they're eating, more of it gets digested when it anaerobic digestion doesn't happen. So basically methane is created by anaerobic bacteria that doesn't have and it happens like even outside of a cow, right? It's like these bacteria, for example, a way to reduce methane in like rice farming is to, you know how like they flood the rice plains,
Mhm.
the rice paddies, because like rice can survive floods, and then all the weeds die. So as long as you actually don't keep it flooded the whole time, and you like unflood it and let other bacteria have a fighting chance, um there's like significantly less methane being produced by the bacteria from making rice, because now the aerobic ones can have a, you know, the aerobic ones are usually a lot better at surviving in soil unless it's being flooded. And
Unless it's
so
flooded. Yeah.
yeah, so like if you do this, like I was gonna say crop rotation, but it's more like irrigation rotation, where you like
Uh-huh.
take the same bank of water. Like let's say you had like a 4 square of rice paddies, and then like you had a way to move the water from paddy 1 to paddy 2, and then paddy 2 to 3, 3 to 4, and like you would just rotate the water between those four. You would still kill the weeds, but you wouldn't like also breed these anaerobic bacteria that like poops out a bunch of methane. And that's like actually a thing they're starting to do now. It's like
Wow.
it does require like some work to move the water in a circle, but it uses
Yeah.
less water, and it, you know, you get the, you know, the weed freeness of it anyway, and you get less methane. Like it's
And
like a
then yeah.
win for everyone. Yeah.
Yeah. Win-win.
So yeah, so that's kind of a thing.
I,
So like reuse, right? Like reduce, reuse
I was
methods.
also reading there's this company that wants to vaccinate cows against the bacteria that like
The
produce
methane
methane.
heavy. Yeah, that
Yeah.
was the other thing. There's also like what are called like engineering bio, they're called biofilm or biome editing, where you like basically give make it more advantageous for all the aerobic ones. Like give them advantage so that they colonize their guts more. And I mean that's basically what the Red Sea weed does, right? Like the bromide, sorry, that's not the right word. The bromoform does that, right? Like it just it feeds certain bacteria better.
Right. So it's like a prebiotic for
yeah,
non-methane producing bacteria.
well, it also like actually inhibits the enzyme that that is used to create methane. So like it makes it harder for the methane production to happen at all. And I don't know if it like, I mean, I guess if you're not going through your full cycle, you might not be able to like reproduce as much as I'm thinking like a anaerobic microbe right now. But I'm not sure if it directly inhibits like microbiome, like the growth of those anaerobic bacteria.
And if you stop them from producing methane, like they produce methane because that's how they get energy, right? So presumably if you stop them from producing methane, that is going to slow down their growth.
Yeah, that's actually, you're right. Yeah. That like indirectly, but yes, I think that's the eventual goal, right? So that's like another, I guess, reduced reuse method, which I thought was pretty cool. And I have one final one. I'm trying to like look for which one it was. The final one is actually because it is currently oyster season, and I'm as a huge oyster eater fan. I was really, I guess like I was just really chuffed to learn that eating oysters is good for the environment, because you always hear about how oysters used to be so plentiful, like it was all up and down the seaboard, and then like we overfished them and we ate way too many of them, and now there's like not enough oysters. And then I'm like, oh, I really like eating them. And I learned that a lot of, at least in New England, they collect, like if you go to a restaurant and you eat oysters, they collect the shells after you eat them and they clean them, like they like process them, so that there's like no more flesh on them. And then they go and dump it back into the ocean in like a really specific pattern, and they regrow baby oysters there. And it like helps create like the places for baby oysters to latch onto, and it's like a oyster nursery situation. And
they like to attach to the oyster shells.
Yeah, to the oyster shells, and there's like a source of like calcium or whatever for the baby oysters. And it's working so well, it's like actually fixing the ecosystem in the, like it's making the water better. Like it's, I mean, oysters are really good at filtering water and cleaning it and stuff, but like by cleaning it and making it better, it makes it better for the fish. It also like makes the floor less barren. It's like repopulating this like floor that like we've like, what's that called, like trawled through like, and like decimated the populations of baby things. Like the Chesapeake Bay is like actively being fixed by us eating oysters and dumping the shells back.
Oh wow. Yeah. Do oyster shells sequester a significant amount of carbon dioxide? Like we talked about that with the plankton.
Oh, that's a good question. I mean, yeah, I guess it's mostly carbon,
made
right?
out of calcium carbonate, right?
Yeah, so... yeah. Oyster shells sequestering carbon ? Yeah, it literally, that's what it does. It filters and processes the gallons of water and sequesters carbon within their shell.
Oh yeah.
Look at that. Our climate warriors, the oyster.
Nice. Oh, interesting. So yeah, there's this paper in PNAS called Oyster Farming Acts as a Marine Carbon Dioxide Removal Hotspot for Climate Change Mitigation.
Yeah. So like oyster reefs, like you can like grow it back. You can help grow it back by feeding it back their shells. And growing a shit ton of oysters is great for it's great for the environment. And it's not just like oysters, right? It's like helping all the other baby animals too, right? Like when you have a nice reef, you like it, you know, it trickles down. It's just like a surprising keystone species. That's
another thing that I learned recently is like it's surprisingly good for the ocean to just like dump random vehicles into it.
Is this the coral growing program?
Like more or less. So it's like it turns out like the military, like when they have a bunch of like extra tanks or whatever that they want to retire, they don't really want their enemies to be able to get like access to them. So they'll usually just like dump them into the ocean. And you'd think that like this would be bad for the ocean, but actually there's quite a bit of research that suggests that these essentially act as artificial reefs and provide places for marine organisms like oysters and barnacles to like anchor themselves and essentially can kind of kickstart an ecosystem in a very barren location in the
Aw.
ocean. And so basically these things act as like artificial reefs. And I just thought it was really interesting that like it's actually like apparently good for the ocean to just like dump tons of trash in there.
Specifically, like large hunks of metal, right? Like
Yeah, like
old
something
subway
that's gonna
cars.
like
Yeah.
sink down to the bottom and just kind of like sit there for a long time and be biologically inert, so that stuff can attach to it.
Yeah, I think
Um,
there's like I remember seeing this article about how all the New York subway cars are all like currently in the Atlantic Ocean. And I think there's a photo of it, and because like some divers went in and looked, and it looks so like it's like Atlantis.
oh yeah. Oh, Redbird Reef, an artificial reef that comprises 714 Redbird subway cars.
Yeah.
Actually, it's composed of subway cars, 86 retired tanks and armored personnel carriers, 8 tugboats, and 3,000 tons of truck tires.
Yeah. And I
Like,
think it's
so this
it's
is
more
really just
common.
like this is really just like a garbage dump. Uh,
Yeah.
but
Yeah.
from 2001 to 2008, within the vicinity of the reef, the amount of marine food per square foot has increased 400 times. So, like, if we want the ocean to be healthier, just like dump random vehicles in there.
Yeah. Yeah.
I'm
X
just
train
really amazed.
cars.
It's just like, how do we improve this ecosystem? How about we just put a bunch of tires down there?
Yeah.
And like,
Yeah.
it
I mean,
actually worked.
yeah, I mean, I'm thinking about like the predators of these animals, right? Like they're natural, these reefs that we've decimated because we went to go fish
Mhm.
them, were made of coral and like like nice soft things that we fucked up, and so now we have to go fix it with less soft, nice things.
Mhm.
And maybe they'll survive better. Like they got an armored home now, and
Like now they can live in a tank.
literally they can live in a tank. Like
Like I'm just like
Nemo's homes.
I'm just really amused by it. Like when you put it by that, it's like, yes, we like saved these endangered octopuses by giving them armored personnel carriers.
Yeah. Decommissioned military vehicles. Very good. I feel like that was pretty fun.
Yeah, that was
Do
fun.
we miss any of our examples? Did we finish?
Let me see. Hang on, I lost the.
Oh wait, we didn't talk about the solar. Oh wait, is this the air pollution one? Oh, I was hoping
Yeah,
for like
yeah.
a space um reflector or something.
Like a space thing. So that has
Yeah.
also been talked about. The idea of like you could put things into orbit and then have them deflect the sunlight. I think it's less mature, but it's definitely something that's been talked about. There's also, interestingly, there's sort of the opposite. There's companies now that are like, they are making satellites that will reflect sunlight at specific locations on the Earth during the night. And it's actually intended to be used to like improve the productivity of agriculture. So like you can have sunlight going to your crops even during the night.
Oh, and so they can like have more photosynthesizing time.
Exactly.
Okay, I can
Yeah.
see that being good,
Which I
and
guess
not be
is
corn.
technically like a global warming mitigation thing too, because it makes them like take up more carbon dioxide. But
Yeah, I mean, if we go through like all the cool other energy, like energies, like ideas are pretty cool too. Like I really like smart grids, which are better at handling energy that's not consistent. which is what wind and solar is. Like solar, you basically get it for like half the day, right? Like when the sun is out, you get solar, and when there's no sun, there's no
Mhm.
solar. And so having smart grids like redistribute the energy that you're getting and then like bringing it back when there's no sun is really useful, right? Like it's actually almost a storage problem than a collection problem, because like the grid has different demands at different times of the day. Like we don't really need to be turning all the lights on in the middle of the daylight hours. You like there's a higher demand at night when you're in the dark when there's no sun. So like it needs to like basically move and allocate energy according to what's needed. So like the smart grids can do that. And it saves a lot of energy. So like there's a lot less waste. Because like right now, even with the old school electrical systems we have, like when we have extra, we literally dump it into the ground, which is wild. I was just like
Mhm.
we literally have like metal things that go into the ground and they're like, we need to dump this extra
Just
energy
to
on the
like
grid.
absorb the extra.
Yeah,
It
and
just
they
like heats
literally
up the
shove it.
ground.
Yeah, it just shoves it into the ground. And I was just like, oh, what a waste. Yeah, so
Wow.
it's really like a energy allocation problem more than
Mhm.
another way to like extend the energy that you're collecting with the sun is like converting it to heat, which is kind of nice. There's a system that they're trying out in the middle of the desert where they like have mirrors pointing at this like giant block of black sand and it just heats up the sand, and the sand is like now hot and has like potential energy, and it can like be warm all night, and so it's like releasing thermal energy, and that's being converted to electrical energy for use. So like
Mhm.
during the day you'll have like direct sunlight energy, and then at the night you'll have like this heat
Right.
this
So you
heat
charge
release.
this. You charge the sand during the day, and then you can use it
Yeah,
as
yeah,
like a
with
thermal
heat.
generator.
It's really fun to hear like all these cool technologies people are coming up with. I mean, there's like these proposals where they're like, we can like use like a little patch of the desert, the Sahara Desert, and like basically solar power all of Europe. And then
Oh
they're
yeah,
like,
I
that
saw
sounds
that one. Yeah.
yeah, like that's been proposed for years. And like the only problem with it is like logistically getting the energy to Europe, right? It's the allocation problem. Like how do you get the energy that you collected in this desert to go into Europe? Like how do you get it to the grid there and get it distributed? And that's actually the most expensive part. It's like
Yeah.
really expensive to build things underwater. It's really expensive to like wire it to, getting the correct AC, DC, like you don't like get the correct energy into the right wires and like and get enough of it. But like theoretically it can be done, and we could be not reliant on if we on fossil fuels and stuff if we invested in it.
Right. That's
Um
like the sort of thing. Like again, I'm just like some rich person should just do this. Like they should just be like, okay, we're doing it. Like just go and like buy the patch of the desert and like hire someone to like send the cables and just be
yeah,
like,
this is one of those instances where I'm like, maybe like if you just had like a butt ton of money, maybe this is like,
yeah.
this could be your. I mean,
If
it's like a butt
anyone
ton. It'll be
listening
like
to this
billions of
has like
dollars.
a couple
Yeah.
$1 billion, seriously consider doing this.
Yeah. Well, and also they would undercut, like eventually they would like once it's built, they can undercut the fossil fuels completely, right?
Mhm.
Like
Yeah.
it's like they don't gotta dig anything out of the ground. Like this is literally free internet, like free internet, free
Free
sunlight.
energy. Yeah.
Yeah, like coming
Mhm.
in. Like you just have to, travel it to the right place. Um and like we say like, oh, this is really crazy and like can't be happen, but internet has cables and the optic fibers in the bottom of the ocean, and people pay for that, and it works, right? Like it could happen, and
Yeah.
that's like these optic fibers that travel, from the data centers to every one of our countries, like that. Someone made that work.
Yeah. There's
Which,
underwater power cables too. Like I think they.
yeah,
Yeah.
I do think power cables are probably more expensive than like optic
Mhm.
fiber cables are. Um, oh yeah, there's these like proposals that are kind of cool. Like I didn't do like super research on them, but I learned about them like en route. Did you know like in the how like in China there's like where Beijing is, there's like the Gobi Desert that's just like
Mhm.
right up against China.
Yeah.
So they built a green wall. It's
Mhm.
literally just a shit ton of plants that like shields the city of Beijing from the sea. I mean, from the sea,
From the
from the
desert,
desert.
yeah.
Yeah, from the Gobi Desert. Like,
Yep.
they're just growing shit, like
Because
all
the
kinds
problem
of.
was like kind of the desert was expanding that way, right? So they
Yeah.
were like, we're gonna engineer this landscape to like prevent the desertification of that.
Yeah, it's really impressive. I was like, wow.
Mhm.
Like, and I mean, actually, to be honest, like China has done a really good job at greenifying themselves. Like partially out of necessity, right? Like they don't have, I don't think they have a huge resource of fossil fuels. Like they don't have that naturally, and so they would be dependent on other countries for it. And so instead, they're like all in on in the environmentally climate friendly chains, and they have proven, because they were all in on it, they have built the technology. They can do it. Like humans can do it on this planet. Like we can do this without the fossil fuels and have the big city metropolises and have the big like energy demand. Like we can fulfill the energy demands of modern modern human life without the necessity of
Without producing like fossil fuel or
yeah
without using like fossil
excessive
fuels.
amounts of fossil fuels. And like for them, it like they literally don't have it, right? Like they would need to buy it and it would just be really taxing. And like think about all the things that we get from China. They're made in China. Like all everything like sewn needs a machine that's working to sew things. Like this is a lot of energy. And so they figured out a way to do it
Mhm.
without fossil fuels, which is very remarkable. And also like I mean, there's like lots of cool things that they can get up and running without it. And also like public transit, they like have they were just like, we're gonna make, you know, high speed rail, and then like 10 years later it's high speed rail everywhere. It's amazing.
Yeah, just
Yeah.
like I feel like it's similar to what we were talking about. They're just like, okay, this is a good idea. We should do it.
Yeah, like all in. And I think that's kind of what we need, right? We need our like
Yeah.
I think that's what you could do on the ground level, right? Like take more public transit. Like these things actually help. Like vote for public transit things. Like whenever it's like, hey, like do you want an extra, you know, subway stop? The answer is yes, because more subway stops means less cars. Like
I think this is a good I was just looking this up. This is a good like positive way to end actually, which is this is looking at the carbon emissions of different groups of countries like over time. And so you can see it's this one actually. Yeah, so you're talking about like the China
the carbon thing. Yeah. And they did
yeah,
it
the
so
carbon emissions.
fast.
Yeah.
In like 10 years.
Yeah. And like I think this is what's really remarkable about like China's emissions is that like it shot up dramatically starting in like the 2000s, which like is because they started making most of the things that are like used everywhere on the planet. But now kind of it looks like they've actually reached their peak like carbon emissions and it might be declining now. Also, interestingly, like the U.S. and the EU also seem to be on that path too.
That's heartening.
Yeah.
The faster the better, guys.
Yeah.
Yeah. And another cool way to track without these numbers, actually, you can just look at this. Where's the? Do you remember the global Earth?
Global Earth. What is?
Global. Yeah, it's called. Here, let me drop this in the chat. It's like a map. You can see real time. All the emissions on the planet right now. So like if you pick particulates, and you can do like you can literally see where the particulates are coming out of, and like what the air quality is in like different parts of the world.
Shit.
Yeah. Oh, and compost. So remember how I talked about the methane? The methane is caused by these anaerobic bacterias. Like if we like what's it called? Trash heaps? Trash landfills. Landfills are full of food that become methane. But if you don't put the food there and just compost it and it just becomes food for your plants, it doesn't become methane at all. So
right. So if you kind of compost it aerobically instead of anaerobically.
Correct.
Yeah.
Correct. And a extra plus for this is that aerobic composting does not smell as bad. Like I don't I like if I think like I guess one of the things that people don't like composting is because like oh it stinks, it's not doing well if you're doing it right it usually doesn't stink that much. Like you're like it should stink less than if it was doing it or anaerobically. Yeah.
Oh yeah.
Yeah. You can click
Let's see,
particulates.
chemicals. Yeah,
Yep.
or particulates.
Yeah.
Okay,
I
so we've
think
got carbon monoxide, carbon dioxide, sulfur
sulfur.
dioxide,
Yeah.
and nitrogen. Oh, actually, so we were talking about the sulfur dioxide. I wonder where it's coming from.
Oh, it's high on the East Coast.
I feel like so I think the main producers of it are like industrial processes, so that kind of explains why there's so much of it in this like Rust Belt area.
Yeah. Oh, it's very like Europe.
Also, it's like all
Asia.
blowing over that way, I guess, is what this is showing.
Yeah. Oh, and it blows into the Atlantic Ocean, I think.
And
Yeah.
Quebec.
Yeah. I really like looking at this whenever I'm like, what's going on? And like, you know, like when there was like wildfires and stuff in California, you could like literally check because like the news was very spotty, like on when things are happening. And I was just like, okay, like let me just look at the particulate measurements we're getting.
That makes sense, yeah.
Yeah, and I got a pretty good idea of like what the fires looked like at the time. Yeah, this is you're looking at sulfur dioxide. That's cool.
Yeah, but then we under it's in biology mode.
Yeah. Yeah, I like this. This is kind of a fun site to preview. And you can also see how good the auroras are because you can look at the magnetic field. Ooh. So if you go into
is it space mode?
Yeah, I think it's space mode and then aurora overlay.
Oh yeah.
Yeah, you can
looks
see
like
how
not really any auroras right now, except I guess for Iceland.
Yeah, but you can see it like you can see it over Antarctica as well. Like you can just like flip the globe over. It's just like a nice like visualization of like all the things happening on Earth right now, and it's
that is cool.
Know, yeah. I like it. I mean, it just like reminds you, like, hey, we live on this like one planet.
It's also it's really cool that we can like collect this data. That we can be like, what are all the winds doing all over the planet?
Yeah. I really like it. I forget where the data comes from. I think it was NOAA, but let me see. Data source. Global Forecast System, NOAA, NWS, EMC, and NCEP. The ocean data. Okay, so each of the data sets come from different places. So it's basically like a meta-analysis of like a whole bunch of different. If you look at
sense.
like if you go to here's the about. Paste. So like if you go to the about, it tells you where their sources are, and it's like live streaming all of these different sources all into one place, right? So like you can just look at it on this globe. It's kind of cool. I kind of want to like have a globe at home, and it's like the forecasting globe, and like have like a physical version of this, like 3D, and have it like basically display this data live. Oh, and another cool thing about this is you can also go back in time. So like it's just like it's showing you like right now, right?
Like
so if you go to the date, you can like change the date. I'm not sure if you the control now you can fly back in time like years, like back to like when it began basically in like 2013. So there's data from like the past 13 years. So you can like fly through and like you can like look on the specific date what it was like on wherever, and then like go look on that part of the planet and then see what the air quality was like, what particulates are, how like just what things are. And I think it's a really cool resource for like just getting a snapshot of what's going on in all the different like all the data is in one place, so you can like kind of play and look at it. I feel
like this is very much like a Californian impulse too, to be like, okay, like let's check the particulate counts for like where we are.
Like let's look at what it looks like in my hometown,
right? Like, so for people who aren't from California, because we have so many fires there, like oftentimes like during fire season, if you live there, you like check like your local particulate counts to be like how safe is it to go breathe the air outside.
Yeah, or if you need to carry N95 when you're
Yeah.
outside. I mean, there was like a day a couple years ago where like San Francisco was like orange. Like it looked so eerie. And I was just like, this is insane. And then I looked it up on this website and I was like, oh my gosh, like a swirl, like right over the city, and you could like track it across time. It was cool.
When I was a
Anyway.
kid, we'd be like, let's go play in the smoke, which like it turns out like is really, really bad for you. But we were just like,
Yeah.
this is
Yeah.
cool.
Cool. We got a bunch of comments from Mind Show.
Oh yeah, Mind
Sorry.
Show. Yep.
Uh
So there was this one about how like about how nuclear testing might cause UFO sightings that I wanted to look into, but I feel like I wanted to read this paper.
Yeah. I feel like it's time for another UFO related one. Maybe
Yeah, we
maybe
should do that.
we'll tease that for next week.
Mhm.
Oh, shoot, I think we're actually out of time.
Oh yeah, I think so. Yep.
Thank you for joining us.
No,
We're
thanks for coming.
Philosophising. See you next week, where we will talk about some other science thing that we
Possible UFO.
decide to talk about. Yeah, possibly UFOs. Bye.
Bye.